guys, my name is Hamza Arshad, and today we will be covering the topic remainder factor theorem under SAT mathematics. Okay, so first of all, let's talk about this term that is called polynomials. So basically, a polynomial is an expression in the form an x to the power n plus a n minus 1 x to the power n minus 1 and so on. This series basically continues until the power of x, right? It was first n, so it will continue until the power of x becomes 0, meaning there is no more x, it's only 1. So um, this is basically a polynomial where x is a variable, n is a non-negative integer, right? So it is the power of x, and then we've denoted an as the coefficient of x to the power n. So basically an, it is the coefficient. And similarly, as the power decreases, then we have n minus 1, then we have a n minus 1, which is the coefficient again of x to the power n minus 1. So this basically continues, and then we also have a to the power 0 for x to the power 0, right? However, since x to the power 0 is simply 1, we write that as a0 only, and we do not write any x alongside it. So here x is the variable, n is the non-negative integer, an minus 1 and so on, these are all constants. An is the leading coefficient because this is the coefficient of the highest power, because of course n will be the highest power. All of the rest of the powers, they're going to be n minus 1, then n minus 2, then n minus 3 and so on. A0 is a constant term, and it is a constant term because there is no x alongside it. There is no variable alongside it. It's simply just the number. So no variable attached. So an example of a polynomial, for example, is here. For example, x squared plus 2x squared minus 11x plus 6. Here, since x cube is basically the same as 1x cube, so this is the leading coefficient. And 6, because there is no x alongside it, this is your constant term. You can see here that the highest power here is 3, x to the power 3, and the next one is then n minus 1, 3 minus 1, so x to the power 2. And then further, x minus n minus 2, so 3 minus 2 is 1. So gradually it becomes 2, then it becomes 1, and then it becomes 0. So this is basically how polynomials generally work. Okay, so the next thing we're going to cover is dividing polynomials. So for example, you have this polynomial which is x cubed plus 2x squared minus 11x plus 6, and we have to divide this by x minus 2. So for this we're going to use a method that is known as long division. So so here the leading number that we have is x cubed, and here it is x. So if we divide x cubed by x, then we get x squared. So let's multiply this by x squared. So if we multiply this by x squared, we get x cubed minus 2x squared. This is 0. This is 2x squared minus 2x squared. Hence, they will be added and you will get 4x squared. Alright, so next up, now the next leading number here is 4x squared. So we're going to divide 4x squared by x, and that will give you 4x. So plus 4x. So multiply this with 4x. Now you're going to get 4x squared minus 8x. This will give you 0 minus 3x. The next leading number here is minus 3x. So minus 3x divided by x is simply minus 3. So now we're going to write minus 3 here, and we're going to multiply this with minus 3. This will give you minus 3x minus 6. Minus 3x plus 6, sorry. And therefore the remainder is actually 0. So since the remainder is 0, we can clearly say that x minus 2 is a factor of x cubed plus 2x squared minus 11x plus 6. So here the conclusion is written: if the remainder is equals to 0, then x minus 2 is a factor of the polynomial. So basically, now let's look at what happens if we input 2 into the polynomial, right? So let's do one thing. The polynomial that we had was x cubed plus 2x squared minus 11x plus 6. So let's input 2 here. 2 cubed plus 2 squared minus 11, 2 plus 6. Now if you solve this, you will get the answer as 0. And what that means, that is basically a proof that x minus 2 is a factor of p. So here we get a rule basically that, just to put it simply, if x minus 2 is a factor, then p to the 2, meaning when we input 2 into the function or the polynomial, this should be 0. To sum it up into a proper form, this is called the factor theorem, and let's see what this basically entails. If a polynomial px divides exactly with the linear factor x minus c to give qx is basically when we divide the polynomial by the certain number, then what expression do we get? That is qx. So x minus c multiplied by qx is basically px. So if x minus c is a factor of px, then pc is equals to 0, and you can clearly see why that would be the case, right? Since x minus c is the factor, then what's going to happen here is c minus c times qx. Moreover, you get another rule here, which is if ax minus b is a factor of px, then p, and if we input b upon a, then that should be 0. And again, we can link that as to if, for example, you have px is equals to ax minus b times qx. If you input b upon a here, then this gives you b minus b, which is 0. And since this part is 0, when it's going to multiply with qx, you're going to ultimately get the value of px as 0. Therefore, if ax minus b is a factor of px, then p of b upon a should be 0. Now we have a few examples here. For example, the first question here is use factor theorem to show x minus c is a factor of x cubed plus 2x squared minus 16x plus 3. This is pretty simple. If x minus 3 is a factor of px, then p of 3 should be 0. So you're going to input 3 into this and you will get the answer as 0. Now we get another question over here. Given that 3x squared plus 5x minus 2 is a factor of 3x cubed plus 17x squared plus ax plus b, find a and b. So this is a pretty interesting question. Let's factorize this quadratic equation first of all. So 3 2s are 6, 3x squared plus 6x minus x minus 2, 3x, x plus 2 minus 1, x plus 2. So if we factorize this completely, we get x plus 2 and 3x minus 1. So this is basically an entire factor. So that would mean that first of all, this is also a factor and this is also a factor. So if x minus 2 is a factor, then p of minus 2 should be 0. If 3x minus 1 is a factor, then p of 1 upon 3 should be 0. So what we're going to do here now is, let's just move aside over here. So the polynomial here in question is 3x cubed plus 17x square plus ax plus b. So what you're gonna do is, first of all, you're gonna input 3, 1 upon 3 cubed plus 17, 1 upon 3 square plus a, 1 upon 3 plus b. And for the next one, you are going to input minus 2 into this. So minus 2 cubed plus 17 minus 2 square plus a minus 2 plus b. And in both of the cases, this should be 0 because these are factors. And so you'll get two equations which you'll have to solve simultaneously. And you'll basically get the answer by doing that. Let's just move on to the remainder theorem basically. So the remainder theorem states that, for example, here, if when we're dividing px by x minus c and it's not basically x minus c is not a factor, then there will be of course a remainder. So one way to write this would be px is equals to x minus c times qx plus r. So basically you can just picture this as this situation, that here you have px, here you have x minus c, and here you have qx, and in the remainder you have r. So we're multiplying both of these and we're going to add r and we're going to get px. Therefore, here r will be the remainder in this situation. So note one thing, that if, for example, we input if x minus c is the dividend, if we're dividing it by x minus c, then if we input c into this equation, then this will become c minus c. This will become 0. This entire thing will become 0, and you will be left with px is equals to r. Therefore, basically, by applying this, we get the remainder theorem, which states if px is divided by x minus c, then the remainder is p of c, because we're basically subtracting c from c, and therefore you're going to get 0, and the only remaining thing in this entire expression will be your remainder, which is r. Similarly, if px is divided by ax minus b, then the remainder is p of b upon a. So basically, like here we have a b upon a minus b plus r. Now since no, actually this and qx, which is the quotient, so it's gonna get cancelled out. Qx times 0 plus r, and that will give you 0 plus r, and therefore r. So if px is divided by ax minus b, then the remainder is p of b upon a. This can also be applied to the factor theorem in such a way that if ax minus b is a factor, then the remainder will simply be 0. And therefore, if ax minus b does not give any remainder, then the value of p upon a is 0. And that is one good way to remember the remainder factor theorem. So this basically sums up today's video.